Hello there. Well, today's little waffle is about sharpening drills, drilling holes, and things associated with making holes using drills and drill bits. I've been asked, how do you sharpen a drill bit by hand? I've been asked, how do you drill out a stud or a broken bolt, and various other things of this nature. So this is the subject for today's little waffle. So this is not aimed at the professional or precision engineer, it's aimed at the rank amateur, the hobbyist, the home machinist, the jobbing builder, handyman, who simply wants to drill a hole roughly in the right place, perhaps to put a bolt or something through. He's not too worried about various geometries of drills, and which is quite a big subject. He simply wants to make a hole. But you'll have to learn a little bit, I'm afraid, because all drills is a big drill. Whether it's that size or that size, the principles are exactly the same and the geometry is the same. So if we're going to sharpen this, we need to know what these angles are. All twist drills, or that type of drill, have two flukes and two cutting edges, and they must be the same. And that angle needs to be approximately, for general purpose use, about 118 degrees, even down to that size. But I can't see that. If I dropped it, I wouldn't know where I dropped it, let alone sharpen it. But anyway, that's the principle. So how do we work out what this angle is? Well, if we've got a protractor, that's terrific. Aha, hang on. Just found those. If you've got a couple of nuts and you put the two flats together, see if I can hold them together. I'll have a go. Aha. You'll find that there's our angle, just there. A couple of hexagon nuts. So glue a couple of nuts together and it'll give you a guide for how to get this angle right. Whatever you do when grinding these, they need to be the same, to be symmetrical. If one of these ends up slightly larger than the other, you're going to have an oversized hole. Also, the cutting edge, the leading edge, has to be in contact with the metal, and the trailing edge, the heel, needs to be lower. And this angle needs to be about, the difference in that angle needs to be about 12-15 degrees. If it didn't, the heel would rub and wouldn't allow the drill to cut at all. So that's the basic geometries of drills. It's far more complicated than that, but before I decided to do this, I had a quick look on YouTube who's doing tutorials on how to sharpen drills, and there's some excellent ones on there and there's some absolutely rubbish ones too. There's a guy, Tubular Chan, he certainly knows his stuff, and a guy that I admire, but I looked at one of his videos and it was 3/4 of an hour long and it was one of 4. Well, I suspect Mr. Jobbing Builder hasn't got that attention span and would have turned off. And then there was other guys. There's one guy, reckon he was a drill doctor or something equal. He was waving a drill around one hand on the side of a wheel. Sparks were flying all over the flipping shop. And how the heck he stayed in business, I've no idea. There was another guy using a wheel so coarse you could hear the drill jump from the thing, and oh well, not here to criticise those, but this is the process I use. So if we're going to sharpen a drill, most jobbing builders, as I say, that's not a derogatory term, most jobbing builders will use the same drill for drilling wood, for drilling plastic, for drilling metal, and beginners also assume that a drill bought new out of the packet from the tool store thinks that they've got a sharpened drill, but of course they haven't. The drill manufacturers can't possibly know what you're going to use it for, and they come up with a generalised starting point, if you like, and that will suit most people's needs. But there'll come a time when you'll need to resharpen them. Now, I've often been brought handfuls of drills. Can you please sharpen these for me, or put an edge back on these? And I say, yes, certainly I can do that, but it's a waste of time. You might as well put them in the bin. I said, you know, you've just ruined them, cooked them to hell, and blue and rounded, and I can put the shapes back on them, but they won't be any good. If you think a drill needs sharpening, it wanted sharpening long before you thought that. So keep them nice and sharp, and it'll make life so much easier. When it comes to sharpening on the grindstone, you sharp only on the periphery of the grindstone, not on the side, okay? You need a nice clean wheel too. This is sort of a medium grit. See if I can go in a bit. There you go. But it's got a bit of muck in there. Someone's borrowed it and probably tried to grind some soft alloys or something, so we got muck in there. So it wants cleaning off. Now, where's me wheel dresser? I've got one somewhere. Is it over here? Never can find it when you want it. I should have prepared. Sorry about that. Anyway, we dress the wheel and clean it up. I'm still looking. I'm blowed if I can see it. I'll stop the video for 1 second. Okay, I'm back. You can use a star wheel to clean the surface. You can use a diamond tool. This is impregnated industrial diamonds to remove the surface. You want nice clean grits. You want it flat across here, and get rid of any debris within the wheel. If you haven't got such things, use a piece of broken grinding wheel. That'll work. So we'll switch that on, and we'll just clean the surface. There we go. We've now got to let that slow down. Shouldn't really do that. Right, we've now got a clean surface to our wheel. We've got freshly produced grains of grit within the grinding wheel. These are the old ones that we've crushed and took off, and we can now proceed to grind the drill. Grinding a drill takes about 15-20 seconds, if that. Describing how it's done, well, that takes hours and hours. It's a very difficult thing to really describe. It's not really so much a skill, or it's more of an art form, something you learn. I'll liken it to riding a bicycle. You can look at videos on how to ride a bike. You can read as many books on how to ride a bike, but none of them will teach you how to ride a bike. The only way to learn to ride a bike, if you don't know, is to get on one. And perhaps after you've fell off a few times, then you start to pick up the idea. And once you've learned, you never forget it. If you've never ridden a bike for years and years, and you get on it again after these years, you might well be a bit wobbly for 5 minutes, but it's something you never forget, and it's the same with sharpening drills. I've used a rest here, but I don't put the drill on the rest. It's only a short little rest. I use it to put my finger on to balance it, and I hold the drill. How best to describe this, I don't know. Hold the drill with the cutting edge above the centre line of the wheel, and I sort of keep that horizontal, and I sort of move it in an arc. The idea is to remove more from the back, from the heel, than the front, so as to give the drill clearance. And how many times you stroke one side, do the same to the other at the same angles. So we'll start the drill up, and here I sort of, like so, turn it over, like so, like so. And that will sharpen up, get it in focus, that will sharpen up your drill good enough for most purposes. Okay, that comes with a bit of practice. We'll just let that slow down. So, how can we refine this? Well, let's pan back a bit. Wrong way, that way. Let's leave that there. What have we got? Over here. Well done. Most drills, put that down for a minute, most drills, or some drills, especially more taper type drills, have a little dimple in the bottom. But even if they haven't, you can still use this trick. Get yourself a piece of wood, like so. Put a screw through the bottom so it protrudes through, and screw on a piece of aluminium or something soft. Then you can lay this on the bench or wherever, place the drill on that pivot point, and then using the forward edge and back edge of the drill, scribe a mark across the aluminium. Turn it round and use the same part on the opposite side and scribe a mark. If you've got one mark there, you've learned how to sharpen a drill. If you've got two, keep practicing till you end up with just one. Then you're pretty much there. Okay, well, here I've turned the fluorescent light off. It might show the paper just that little bit better, I don't know. Anyway, we'll try it. There's lot more to sharpening drills than I've just briefly shown you. It's a very complicated subject, and this is not the purpose of this video to describe all those processes. So I'm keeping this very simple. Let's assume we wish to drill a hole reasonably in precision. So we will probably mark something and dot punch the centre where we want the drill to go. And say that's the finished size of the hole we want. Not very well drawn, I admit, but that's the hole we want, what we're going to have. If we just gently start the drill so as not to go the full width of the diameter of the drill, and we take a look and we find we've got a hole like so, we can see here that we've got a greater gap at the top than we have at the bottom. In other words, the hole's not in the centre. It's not exactly where we want to go. We really want it to go in that direction. So we can actually, before we get to the full width of the drill, actually draw this drill in the direction we want to go. Now if we get a sharp cold chisel and do a little tap on this face there, I hope that's showing up, yep. Then as the flukes of the drill come round, and we just take a gingerly cut here, as the flukes come round they'll drop into that little groove. At the same time the opposite fluke will have less pressure on this side, and the drill will go a thou or two in that direction. Take a very fine cut, and we should end up, if that's the hole we want, and we haven't yet gone to the full width of the drill, we find it should be like that. If we find we want to go that way just a little bit, we do the same process. We put a cold chisel in there until we get it exactly where we want. When the actual drill, and this is the surface of the work, when the actual drill is gone through the surface so that we've got this full width, so you can no longer draw that drill. It is only between this amount and this small amount that you'll have you'll have the opportunity to position the drill exactly where you want it. And this is most important if you want to drill out a stud. You've got to go straight down the centre of that stud in order to collapse the threads inside the casting, what have you. Okay, it goes on from there. when we've marked and pot marked the place where we want to start drilling, there's an interesting point here that I should mention perhaps, and the reason why we do these things is if this is a cross section of a piece of metal, this is the metal this side, that isn't, and here's our, not very well drawn, but that'll do. There's our dot punch that we're going to pop into the surface of the metal. If we've got a magnifying glass or a microscope and we look at where we popped this, we've got the shape of that point in the surface of the metal. So where has this disappeared, this V of metal? Where has it gone? Well, it hasn't gone anywhere. All you've done is you've disrupted this area, and it's actually mounded up on each side, like so. In other words, you've produced a crater, and the rim of the crater is raised above the level surface of the material. Now comes down our drill, and our drill is much bigger, and this chisel point now tries to find the point that you've popped, but it can easily ride on the top of this crest. So the point of this little bit of the waffle, well, if you've if you've dot punched a piece of metal and you've raised these edges up, just pop a file over the top, a couple of strokes to remove those, and you're more likely to get the drill in the centre. Now let's move on to work hardening type materials such as stainless steel. Every time you bend, hit, strike, saw or do anything with such materials, they become work hardened. So by dot punching a place on a piece of stainless steel, because you've done that, it's now harder there than the surrounding area. So it's a catch-22 problem. When it comes to drilling stainless steel, you don't actually force the drill into the work, but you are forceful. There's a difference. You keep the pressure going. If the drill should dwell only a few turns within a hole, it'll work hard in that area, it'll polish it up, and that section of the hole that you've drilled right there will be very bright and very hard and a devil to get through, and within less than a second you'll start to destroy the drill because it'll just generate heat through friction and you won't make any progress. So the idea is to keep the drill progressively going through the material, and it needs to be sharp to do this. When dealing with stainless steels or work hardening materials, it's a good idea to use a cutting compound. Let me just pan back. Okay, well I'll put the light on, that should help. This Templar's Themaxol, nothing to do with this company. Bought this tin years and years ago. It'll outlast me. If you buy a tin that size, it'll last you for the rest of your life. I keep some by every drilling machine, I use it a lot. It's a sort of a yellowy paste look. You need the tiniest amount on the material you're drilling or the end of the drill. It'll greatly help machining of all sorts. In a drill you'll probably get a little whiff of smoke come up. There's nothing wrong with this, that's quite in order. What's happening is you're generating heat at the cutting surfaces, and that smoke is as a result of this tallow type material melting down and releasing the various cutting oils that assist in cutting and drilling. This can be used for hacksawing, it can be used for cutting with dies and taps. As I say, this is a £1 net tin. I'm never going to use all that, so for a few quid, invest in it. I'm not a a great believer in various oils and things. In fact, I use it. Perhaps I'm addicted to the smell of this stuff. I tend to use it on all metals actually, except of course brasses, aluminiums. I use those dry usually, and cast iron I drill those dry too. Might use a jet of air to clear the chips, but that's all. So cutting fluid to be used with work hardening type tough steels. When we've drilled our hole, let's assume we've just drilled this hole or that hole, whichever. This is in my table saw. I didn't drill these, they were there, but let's assume we've drilled a hole and we want to just chamfer the edge. It makes it neater, takes that sharpness away, and it's more professional. Do not use a larger two-fluted drill to do this. Even if done very slowly, because it's two flutes, it will chatter and you'll get not a very good finish. It's far better to use a countersink or a multi-fluted drill, but it ideally wants to be an odd number of flutes. There's 3. I suppose that's the least odd number you can have. It's the principle of, I just use that, it's the principle of a 3-legged stool. It will always stay steady and not rock, which is why they use an odd number of flukes. So countersink, not with a larger drill. Okay, well we've touched on sharpening drills and we've touched on drilling holes and so forth. It's as I say, it's a very big subject, and we've only just scratched the surface. Well, by now you should, if you're still with me, you should have gathered this is quite a biggish subject that I've only just scratched the surface on. When it comes to just straightforward jobbing drill bits, I've shown a sort of dummies approach on how to deal with this, but when it comes to multi-flute tools such as milling cutters, here in the holder we have to use a cutter grinder. This is a homemade cutter grinder, and here we've got very fine adjustments for angles and amounts of feed and so forth, and that's probably beyond the realm of this particular video. Yeah, I think I'll leave that for another time.